Hi everyone, my name's Nishal Shah, and this is the talk on lightning security within components. This is my coworker Prashant. Before we get started, I just wanted to personally apologize due to the scheduling error yesterday. This talk was scheduled for yesterday and there was a scheduling mix-up, so wanted to apologize for that. So let's get started. So like I said, I'm Nishal Shah. I'm on the product security engineering team. We deal with we write our own tools for the security team. We open source them. You may have seen us at the open source booth earlier today or yesterday. We also do security review for the App Exchange, and we also work with our engineering teams internally to make sure we're releasing the most secure products that Salesforce can.
Hi everyone, I'm Prashant Kannan. I also work in product security team along with Nishal. I manage security posture for one of the public-facing cloud. I do App Exchange review and also develop some internal security tools. So Nishal will be covering the first part of this section. I'll go over the second part of this section. Yep.
So one more thing before we get started. You should make all your purchasing decisions based on products we have out today. So I'll leave it at that. So today's agenda is we're going to go over a brief intro to Lightning. So some of you may be looking into bringing Lightning into your organization and want to understand the risks involved. Some of you may have already done so and just want to make sure you're on par with what the security mechanisms are in Lightning and what you should be aware of. And so we'll go into both of that. And we also have a part 2 of this talk, which is in this theater right after this talk. So it's 11 o'clock. We'll be presenting that one at 11:30. So stick around for that. And then we'll get into Q&A if we have some time. All right, so let's get started. So a brief intro to Lightning. So what is Lightning for those of you that haven't migrated? So there's 4 major parts. There's the Lightning Components Framework. So this is your components, your apps, the UI button, basically everything that's you're writing on the framework. So the shareable components, Aura framework, all of that falls under that. The Lightning experience is the UI for Salesforce. So the major thing there is, our users, your customers expect to have, modern UIs with, JavaScript-driven web applications, and that's what the Lightning experience allows you to do, is bring those modern web applications to your customers. The visual building tools is what allows you to create Lightning components with clicks, not code. So that's very useful for those of you that don't want to dig into the Lightning code too much. And the Lightning design system is actually an open source design, CSS and HTML pack that we've open sourced and allows you to build really cool Lightning components that look good without having to be a graphics designer. So that's the Lightning design system. A lot of this talk is focused on the Lightning components framework. That's really where a lot of the security work is done, and some of the security mistakes we've seen over time, that's where they pretty much lie. So what is a component? So all of these red boxes you see above me, those are all components. Components can be nested within each other, and they can be placed anywhere on the page. So the first thing we see is a graph, which is the quarterly performance. So that's pretty simple, but if we can look down at the bottom, we see a component called top deals. Within that red box, we have more red boxes, and those are more components. And we have a specific deal type, the United Oil Refinery supply generators, and then 2 more below it. And we can see that these components are nested within each other. We could have easily moved this top deals component to the right side of the page, and it's important to remember for the security considerations we'll bring later on. And you can even see on the right side, the assistant, we have, again, 2 more components, and then there's buttons on the side which are actually components within themselves. So there's a lot going on in this page. So this is what a component is, and just keep this in mind as we go forward. So what I want to do quickly now is sort of compare and contrast Visualforce versus Lightning, and basically you'll have an idea of maybe some of the newer security considerations before we actually get into the details. So for Visualforce, the user requests a page, pretty straightforward. That page gets sent back, returns the HTML. The browser displays the HTML, nothing fancy. User interacts with the page, right? But this is still Visualforce. So what happens when the user starts interacting with it? It goes back, makes this whole round trip. Latency is really high. This is not what our users expect for modern web applications to look like. So but there are really good things about Visualforce, right? People understand how it's worked. It's easy to develop for. We have a natural way of splitting applications into pages, which are like smaller components almost. And there's built-in metadata integration, so really, really useful stuff. But the issue, like I mentioned, is that it really doesn't support the modern web applications and being JavaScript driven. So what was the next solution? Visualforce as an application container. So this is pretty similar, and it's trying to get Visualforce one step closer to that modern web application. So the user requests the Visualforce page. JavaScript includes, etc. Pages returned to the browser, straightforward. Browser loads the JavaScript into the application. The JavaScript application generates the UI. The user interacts, but instead of going all the way back to the server, we're just executing JavaScript within the browser, so we're getting closer. We've gotten one step closer to these interactive experiences, but there are issues here, right? It's really complicated, no built-in metadata integration. We aren't aware of the context that we had in Visualforce, and the developer experience was not something a lot of our developers were happy with. So with that, we have Lightning components and the Lightning framework. Right? The user requests an app or a component. An app is just a bundle of components. And that bundle is returned to the browser. The browser returns that bundle, or loads the bundle, and the JavaScript application generates the user interface, straightforward. User interacts with the page, and we still get that short cycle. Right? So what's the advantage of this over the previous Visualforce in an application container? We still have the modern web application experience our users expect. It aligns with the Salesforce UI, and you're integrated with the container, but you also get metadata integration, which is a huge win, and we have a much better development experience. So we definitely recommend using Lightning components going forward. So with that being said, hopefully those of you that haven't moved to Lightning sort of understand what the differences are between Visualforce and Lightning now. So with that, I want to go into some broader Lightning security considerations, and then we'll go into actual issues we've seen during our security review process on the App Exchange and whatnot, and things you should be aware of when you're developing for your own organization. So we saw this page a little earlier, but what I want to now emphasize is that from a security context, what is happening here? All of these components share the DOM. Right? We never had this before in really many other frameworks where you can have a managed package that's writing all these components. Now your internal Salesforce developers at your own company is writing components, and they can live on the same page. They can live anywhere on that same page. And so you really don't have much control over where your component is going to be placed. And that takes away a lot of the security assumptions we had before in other JavaScript frameworks that you may be familiar with. So there's three big themes I want to think about here. So when developers ask us, how do you do these security reviews, or what are you always thinking about? And these are some of the three big themes you could maybe boil down to when you're thinking about security in your own application. So always consider the user as a potential attacker, right? The user can send you malicious input, and you should be ready to handle that, and your application shouldn't be spewing out, sensitive data within your Salesforce organization. That's important. The second one, and it's pretty similar, but I want to differentiate, is the client being the attacker, right? A lot of developers think that, the user only has control over certain input. Well, that's not really true, right? The attacker really has control of whatever gets sent over the wire, and that being the client, right? So anything that's sent to your Apex controller, any of those values, those are controlled by the attacker in the security world. So you have to be really careful between what is your user experience, but you also have to be careful in terms of, hey, we have these variables getting fed into our Apex control on the server side, but all of those values are actually attacker controlled or potentially attacker controlled. And so you guys always remember, where is the attacker coming from? And we'll focus this talk on those first two themes. The third theme is the other component being an attacker, and this is what I was referring to in that first slide. We're talking about the shared DOM between components. And so there's some interesting security considerations, especially with this topic, that you may not really have seen with other JavaScript frameworks, and that'll be the focus of our second talk, which is happening at 11:30, same theater, so stick around for that. So I've sort of given a brief overview of Visualforce versus Lightning, some important high-level themes about what to consider. Prashant, my coworker, is going to take over and talk about some of the specific issues we've seen on the security review process and what you should be aware of.
Thank you, Nishal. That was a pretty good introduction. Access control issue is one of the most common security issue that we find during AppExchange security review process. If you are new to Salesforce development or Lightning platform development, then this section is pretty important for you. As Nishal mentioned earlier, all the logic is in client-side JavaScript. But whenever there's any database call, it goes to the Apex controller. The Apex controller here runs in system context. It's not aware of what user context the query is being called upon. So there's a responsibility on the developer to make sure he does proper check before database calls being done. Oh, it's the other way around.
Down.
Yep. So this is a good slide to understand access control in Salesforce in general. So we have CRUD check. So an administrator can restrict access to a particular object, like contact object, account object, or an opportunity object here. So when you do a query to any object, so make sure you do a CRUD check to check if the user has a particular access to see that object. And the second thing is field level check. An administrator could restrict an access to a particular field, like probably a social security number, or he doesn't want to see the mailing street here or the mailing city for a certain set of user. So when you do a query, you have to make sure the user has access to every particular field when you do the query. And then another thing is sharing. Sharing is more access related to individual records. So the user who created a record might feel that these sets of record, certain users should not have access to. I think. Getting used to this remote now. So as you see, CRUD is more controlled on profile and permission sets, and FLS also follows the same pattern. But sharing, on the other hand, has org defaults, role ownership, and follows the sharing rules. Let me do a quick demo here. So I have this very simple Lightning app here. So what I have is it shows opportunity name and the amount field in the opportunity object. So this is a component which pulls opportunity name and opportunity amount. And I have the client-side controller, which gets it from the backend. Oh. So I have a client-side controller, which is querying the backend controller here. If you see, I haven't done any checks on the object or the field here. Forgive me for this. Looks like, yeah. So now this is another user in incognito mode. So this user does not have access to the opportunity object or the opportunity field here. We can see that clearly. Now if I refresh here, through this app, he has access to all the contents. Now I'm running it here with sharing and removing my comment here. And then here, if we look at the code here, I'm doing a check for the object and also check for the field amount. I'm not doing for the ID and name here because they don't have any FLS and it's associated to the main object. It's also a required field. And record level checks also done. Now, admin has access to all these records. Now, when I try to open it with the user with limited privileges, then he cannot see any of these records because all the permission sets are being respected here. And another one is cross-site request forgery. It's one of the top 10 web application vulnerabilities. Unlike a full-stack cloud, Salesforce has some default protection with Aura token in Lightning. But there are few caveats here. If you do any state change on the page load, this is a code that it's a modified version of one of the code that we reviewed. So here, what happens is a state change is done on page load. An account object is being created. So what happens is, what an attacker could do is, he can make a user open www.attacker.com. In that, he can have like a multiple iframe or a multiple image tag opening that link. So that link will call the constructor multiple times, and it will create accounts all those times and will exceed your governor limits. It's more like a DDoS attack. And there's another case also where in this demo I'm going to show you how how a delete operation is being done. So the same app here, I have a init constructor here. I call delete account on page load here. So I do CRUD check here. The user has complete permissions. I check he has permission to delete or not. And then I do delete here in that object. Now, what an attacker could do here is, he could send this link to the admin and say, hey, this link has the new Game of Thrones episode. Probably you should check it out. And the moment he clicks it, he's not aware that a delete operation is being performed on the page load. And when he comes back, he sees none of the record exists here. So make sure you don't do any state change on page load. It's also a poor programming practice. If there's a genuine use case for you, like you have to do any update, any custom settings, or any add a record value on a page load, you use a conditional loop and make sure it runs only the first time. Okay. Open redirect is also one of the top 10 vulnerabilities, OWASP vulnerabilities. So here, it also happens because of poor programming practice. This is a modified code from one of our partners. So what happens here is, from the page URL param, the URL param is being sent to set events param. So what an attacker here could do is, he would make use of this page. He would put force.com.app, whatever the app this is, and then he would put the URL parameter to like www.attacker.com, and he would have this link and send it to someone. People will think that this is salesforce.com, this is a trusted website. It's totally fine. The start of the URL looks perfectly fine. So once they click, what happens is that attacker param comes to this URL set param, and then the page gets redirected to attacker page. There he can have a login window asking for the Salesforce username and password. And once he enters it, all his credentials are lost. So if you want to have like an open redirect kind of case in your app, what you have to do is you have to have a strict whitelisting. So you can make sure that you have only certain set of websites are being redirected, not any other website. Some of the developers in the past have asked me if they can use blacklisting, like they have like some 100 set of website where they can put it up. That doesn't work, right? I can create Salesforce 1. I can create like another attacker2.com, attacker3.com, or another website. So whitelisting is always a best practice if you have a case where you have to use open redirect. And another issue is cross-site scripting. If you ask any security engineer, they'll say like, cross-site scripting is one of the most common web application vulnerability. It's number 3 on the WASP. Fortunately, if you are a developer in Aura, our frameworks protect from all types of cross-site scripting, except for a few cases like these two. These are the only two things in Lightning. If you go to Lightning security module also, we cover this part. So the component markup is rendered differently compared to a Visualforce page. So no HTML parsing occurs during component rendering. So here it's a URL context here. So what an attacker could do is, if it's a user controlled input entered into v.foo, he can have like a JavaScript colon and put his payload, so his JavaScript gets executed. It could be a DOM base if the value is taken from the component and put in here, or it could be a stored if value from the object.value is put in here. And the quick fix is to have a small sanitization function in your client-side JavaScript. So here I take URL param and then check if it's HTTP or HTTPS or HTTP protocol, and then I return the URL. If not, it returns null. So it runs that this function ensures that it's in HTTP or HTTPS context. It prevents JavaScript and data URI context. And another thing to note is, even if you don't use the sanitization function, modern browser prevent this type of cross-site scripting because there's CSP. We have inline CSP in force.com. So whatever JavaScript is there, that never gets executed because it's an inline script. So we have some of the users who use older version of IE, and it could be someone using even Netscape. We may never know. So we have to keep in mind those users in mind when we develop an app. So make sure you use the sanitization function. This is a quick fix, and there's also another one where in the URL param you can add a slash. If you go to Lightning security module in Trailhead, we have explained that again there. So if what I said was too complicated for you, these are the key takeaways for good programming practice. Properly enforce access control all the time. So there have been developers who write like a huge app in Salesforce. They have 1,000 SQL queries and 500 DML operation, and they do CRUD check after they develop the entire app. They can't go and search all these locations. So have this as a practice. Whenever you do any DML operation or SQL query, make sure you do CRUD FLS and run your class with sharing. And then second thing is to prevent cross-site scripting, don't do any DML operation on page load. If there's a case you have to do, have a conditional statement and make sure it runs once. And to prevent open redirect, make sure you whitelist redirect website whenever you pass into URL params. And fourth is sanitize href and iframe source attributes. That will prevent cross-site scripting.
Next slide. Next slide.
Yeah. So we have 2 talks after this. This is the first part of Lightning, where we talked about Lightning security within components. There's going to be a second session where Nishil and Ryan will be talking about Lightning security across component. Please stay on for that. And then after that, we'll be talking about some of the security tools that could be used to find some of the security issues. So stick around for that. We'll be around here, almost our time got over. So if you have any questions, you can come over and ask. And we have also a booth right over there. Some of our security engineers are there. You can go write them and ask any security question. They would be able to help you out. Yep. Thank you.
So hi, everyone. Welcome back to part 2. Sorry about that intermission. But this talk is Lightning security across components. And for those of you that are just joining us, we wanted to apologize yesterday for the scheduling mishap. This talk was scheduled twice, and there was some scheduling issues, so personally apologize for that. So let's get into it. So I'm Nishil Shah. I was one of the previous presenters on the last presentation, so hopefully you remember me. And this is my coworker.
I'm Ryan Flood. You've probably seen me before with Lightning talks for years and years, and I'm actually supporting Adidas today, unlike our last presenter who was rocking Nike. Clearly not a Commerce Cloud customer, but we're working on it.
Slowly. All right, so we're both on the product security team. So just what we do is we do the security review process on the App Exchange. We also open source some security tools, and we work with our internal engineering teams to make sure we're building the most secure products that we can. forward-looking statement. So make sure you make any purchasing decisions based on the product we have out today. And today's agenda, we did a brief intro to Lightning in the previous one. We'll just quickly go through that and go over the highlights. It won't be as extensive as before, but for those of you new joining us, you won't be left out. We'll go into more specific security considerations that we hinted at in the previous talk, locker service and content security policy, and how that plays into your Oregon components. And then there's a lot of people that say locker service doesn't allow us to do something, and we're going to talk about the solution using component communication. And then we go into an interesting third potential attack vector that we've lately, just very recently, are seeing on the app, on the security review process, and we just wanted to bring it into the light and make sure this, you guys are aware that how to fix these sort of attacks. And then we'll have some Q&A, and then we'll also be at the security booth until 2, so you can also visit us then if you have maybe more one-on-one questions. So Ryan.
Yeah, thanks, Nishal. So you probably saw this slide in our last talk. Oop, other way. But I'm going to give it to you again for those of you who are just joining us. Lightning is awesome. Lightning's amazing. There's a little bit of confusion about what Lightning means. And when we're talking about Lightning, there's 4 different things we can refer to. We have our Lightning Components framework. This is the tools you use to develop. It's your components, your code that we're actually writing and using to make custom, awesome applications. The Lightning experience is the end user facing part of Lightning. It is this big, beautiful UI right here. You cannot see my laser pointer, sadly. But there was a laser pointer up there. And it's the good UI that you all know and love and makes you 40% more productive. We have our visual building tools. These tools are things like the Lightning App Builder, the Community Builder, where you take components, build apps out of them, and create awesome experiences for your users with clicks instead of code. And lastly, we have our Lightning Design System. This is an open source collection of HTML templates and CSS elements for you to create programs not necessarily on the Salesforce platform that meet our styling in. Like Nishal said, what is a component? We've circled them all or boxed them all in red. The important takeaways here are components can have the same data. And the example of here, we have United Oil and our United Oil installations versus the plant security. They're mostly the same. It just shows the name, a date, some amount. Components can have different subcomponents. So if we take a look at our assistant up there, we see, while it's kind of the same, we have different actions we can take off components. And one thing we did not show on this slide is components are rearrangeable. If we want, we can move the assistant over to the left, get rid of this performance graph entirely, take these recent records, make that the most important thing for our users, depending on our use case. That involves a lot. Nishal, do you want to tell us a little bit about what security considerations we bake into this?
Right. Thanks, Ryan. So we'll get on to it. This is just the slide Ryan presented, but now we're going to talk about it in a security context. So what is important to remember is that these components all share the same DOM. These components can be placed anywhere on the page. And like Ryan said, components can be removed entirely. So you don't have actually too much control where the component is placed on a page as a developer. You can't make assumptions on what component is next to me because that may not be actually what the page is displaying. And so with that, there are some security assumptions that are broken compared to other JavaScript frameworks. So we'll get into that and how different, especially in this talk, how components can influence other components in an insecure manner and what sort of issues you can run into with that. So these are the 3 themes I talked about previously, and I just want to reiterate here. So we saw that the user being an attacker, right? A developer should always assume that the attacker is a potential user of my component, of my app. And you should assume that any input, user input, is malicious. Right. With that being said, sometimes developers get a little confused, so we wanted to bring it out, highlight it even further. And the client being an attacker, right? It's any data that gets sent over a wire. So if you have an Apex controller on the server side, it takes in some values, some parameters, and that you can execute on, right? And that comes from the Lightning framework that the component sends off. That data shouldn't be trusted because that is coming from the client side, and ultimately the attacker can control this. So you should always assume when you're doing server side that whatever the client is sending you, you need to validate first. So this talk, we're going to mainly talk about this interesting paradigm, the other component being an attacker. Like I said, components can be placed with other components. You could have a managed package that you downloaded from the App Exchange, and you could have your own internal Salesforce developers writing components, and those two components can live on the same page. And so you have various authors of different components. They can be placed anywhere on the page. So there's some interesting considerations, and we'll be focusing on this third theme in this talk. So Ryan's going to talk about some locker service. So you may have heard about it, and I don't want to take his thunder away, so I'll let Ryan take over.
Thanks. So locker service. It is basically keeping your component in those red boxes we talked about earlier. A lot of people have been hearing about locker service. People have been scared of it for a few releases. Well, locker service is here. It's wonderful. It's on by default for everyone. You can't turn it off. This is amazing. This is a huge security win for all of us. But what does it mean when you're actually working and building Lightning components? Well, you don't have access to the real DOM. You have access to your component's sandbox, and that's really about it. So instead of your window element, you get a secure window that we've provided. Same with document, same with element, same with a bunch of other browser APIs. You don't have access to the real browser client as much. And when you're using these secure windows, when you're using the secure element, you can't reach out of your component and mess with Salesforce code. Similarly, if my component is living next to Nishal's component on this homepage, Nishal's component, when it's trying to grab all of the inputs, won't accidentally grab mine and autofill it for me when it's his code and in a different namespace. An easy way to make sure you're locker compliant, switch your code to API v40 or above, run it again, make sure it works, because this is how we know that the code is running in a secure manner. But locker service isn't just sandboxing. Locker service also protects you. It provides lines of defense against cross-site scripting. We have automatic attribute escaping in most contexts. So if it's just a naked merge tag directly in between HTML elements, you're good. If you're in attributes, you're good for most attributes, with the exception of some dangerous ones like href or iframe source. When we roll out CSP is an optional critical update now, but when we roll out CSP, if there does happen to be an XSS by something we missed or something you missed, the browser will protect you against the exploitation of that with unsafe inline and dropping eval. Lastly, JavaScript strict mode is enabled with Locker, making sure that we write clear, understandable JavaScript apps by using a limited but well-defined subset of JavaScript. One note, actually, and I know this has been a big issue for some of our partners, is JavaScript strict mode will break certain third-party libraries. Maybe your old version of jQuery was not written to be compatible with JavaScript strict mode, or your special widget to integrate with your custom map solution isn't written in JavaScript strict mode. I understand that. That's difficult. We have a whitelist on our documentation of libraries we know that are big, common libraries pinned to the version numbers that work in Locker. I would recommend that you look at that if you want some of that functionality. But Nishal, I understand we have a demo.
Yeah, so just wanted to show, basically, we talked about this API v40 and upgrading components from previous API versions to this new API version. So what does that actually look like? And just wanted to demonstrate that. So here, we have, so basically what I'm going to show in this demo is we're going to have a managed package, and we're going to have an unmanaged package. The unmanaged package written in the C namespace, so my own org's namespace, and the managed package running in the df17s security namespace. And what we're going to show is that the managed package is going to try to reach, the managed component is going to try to reach into the unmanaged component and actually manipulate the DOM. And we're going to show that now. So we have this application. The application is actually running on API v40. So that's interesting. Oh, is it started? Did it play? No. So, right, so this is all the code. Simple. We're running on API v40 just to prove it to you. And then I just made a note of it. And then if we go into the actual unmanaged component, this is running an API v41, so even newer. And we just create this list with an ID, and we have this unmanaged component. Oops, okay. So we have this ID here, and if we keep going.
So this is the code for the managed package, right?
Yes, this is the code for the managed package. Whoop, did I skip forward? Sorry. So this is, hold on, this is, okay, sorry. So we're going to back up a little bit, excuse me, and this is going to be the unmanaged package component running on API v41. And then we have a managed component, which is called locker_protection. And we're going to look into what that looks, we're going to look at the code for that. And we can see here that it's running, so API v40, run it. And we can see actually locker service protected us here. And now, if we look at what happens when we do the same thing, but we're going to run. So this is the exact same code, nothing's changed. This is still the unmanaged component running on API v41. And this, we're going to look at the managed package code, which is called locker protection. It's the exact same code. And just to prove it to you, we're going to go into what that looks like. And we can see that this one has a global, it's a global component. Just for the demonstration, it's a managed package, just to make that specify. And in this case, we actually have API v38. So we're a little bit older. And just to prove it to you. And so we have an ID called ID, straightforward. And just to show you some of the JavaScript code, that we're actually, what this is just going to do is just going to create like 1, 2, 3, 4. Nothing, right? It's just counting. So I just want to go slowly here so you understand the code that's going on. So we're just getting an ID, document, get element ID, and then we're creating an element. So we're just counting again, 1, 2, 3, 4. And we're just going to append that to the DOM. Yep, and that's appending. And now if we go back and we actually look at the application, we can see, and now we hit the count higher button, we're counting 1, 2, 3, 4. Oh, yep, application still v40. My own component's running on 41, but the managed component is running on 38, and we hit the count higher button here. We can see that we actually manipulated the DOM. Oops, sorry. We actually manipulated the DOM of another component, right? So the issue here was that locker service wasn't enabled in 38. We switched it to 40, and we saw that it was enabled. So we saw that the DOM was being protected by locker service on when the component was actually on 40. So it's important to note here. We saw what's going on. It's important to note that even though my own component had 40 and my application was 41, the attacker's component was 38. So locker service is actually enabled, is only isolated based on the component that I actually have. So if I am on 38, locker service is enabled for me. I can still access the DOM, even though maybe Ryan's component is on 40. So you have to make sure that all of your components are running on 40 to get a full protection from locker service. It's not just about my components running 40. So.
Not only that, on the App Exchange, we do not accept components that are less than API v40. If you are running without locker service, you cannot sell on the App Exchange. Period. End of discussion. But let's take a look at what just happened, right? The old documentation we used to have said only use component.find because that will respect our sandbox. But before locker service, if you use document.getElementById, we run into the issue we just demonstrated. So this is the old documentation. Now we can do this just fine, provided you're on API v40, and we are good to go. We're running a little short on time, so let's kind of try and speed through component communication.
So a lot of the issues with locker service is, hey, I need to manipulate these other components to do something for my business use case, how do I still do that with locker service enabled? It seems like this is a big blocker for me. So there's something in the Aura framework called component communication, and what it actually is Aura events. And it's a pub submodel, publisher subscriber. So basically, you have a listener and you have a publisher for a event. Publisher of the event says, hey, something happened. It's like me shouting into this room, you all hear it, but I'm not telling you what to do with that information. That's the same paradigm going on with component communication. If you stick to the old model where I manipulate the DOM, you really aren't getting a lot of code reusability, right? I'm assuming that this other component is on my same page to be able to manipulate that DOM. But in this case, I don't really care because I publish some sort of event that's happened. What the other components do with it is none of my concern. So this is a really good security win. You get code reusability because now you're not have these dependencies on component A and component B and component C. They're very modularized. And it's scalability because I can publish one event and 1,000 components can react. I don't have to manipulate the DOM for 1,000 components. Those other components will know how to react. So with that, we want to go into the interesting potential security issue that I hinted at before, which is the untrusted global attribute.
Thanks. And this one is really strange, and I'm super excited to get to talk about it to you. So, what's the issue with global attributes? Well, if you remember our big takeaway earlier, other components are attackers. And when we set component access and attribute access to global, we allow other components to embed us and to actually take this data and give it to us. But we also talked in the last talk about dangerous context to put data in. And in this case, we're taking a look at specifically two of those. iframe source. We used to talk about putting JavaScript in here if it's from the user. That's dangerous because it could lead to cross-site scripting. Similarly, if we take this unescaped data from a global attribute, that means another component could include us and embed a malicious page into our application with this iframe. They could, for example, register evilsalesforce.com, put that iframe in, make it look like Salesforce with a login page to attack our users. That's not something we want to do. Similarly, unescaped HTML is an Aura tag that does not do any escaping. It's a dangerous tag. Similarly, we do not want to put unescaped data from another component into that. Any data that comes directly from a global attribute should be considered malicious and should undergo a similar sanitization process as we described in the last talk. Now, what you sanitize and how you sanitize depends on the context. If it's a URL, you have to do it one way. If it's HTML, you have to do it another way. I'd recommend taking a look at our secure coding documentation for how to do that properly. And I believe we have a demo. I think we should skip that since we're just about out of time. Come talk to us later, though, if you want more information on this type of attack. But initially, you want to take us home?
Yep. So the three key takeaways, if you didn't understand anything, you should visit us at the security booth and talk to us. But the three main things for you to take away as developers or admins is try to upgrade all of your components to API v40 and higher. You should also insist on any of your partners that are developing code for you to make sure that they're upgrading all of their components to 40 and higher. So that way, locker service is enabled for all of your components across the board. Second one is you should treat global attributes as malicious, and that goes back to our one of our key themes about the attacker controls global attributes. There's another component that's giving you data, and you're somehow rendering it onto the page. And we have a demo for that. We can show you at the security booth. We ran out of time. And the third one is use Aura events for component communication. This makes developers' lives easier. It makes assessing the security of your components much, much easier. So those are the three big takeaways here for this talk. And if you have further questions, come visit us at the security booth.
Where's that security booth?
It's back right in front of the admin theater, just behind us. So just a few steps away.
Cool, and we have about one more talk that should be going on very soon, getting the most out of security scans. I recommend you take a look at that, to look at our scanners, which actually can detect some of these issues for us. But thank you for bearing with us. I realize it's been a long conference. I realize most of you are tired from all the parties and want to go home, but we appreciate you taking the time to learn about security. If you have any questions, come up to us after the fact. Come see us at the booth. But thank you for an amazing Dreamforce, guys.
Yeah.